Hello there. So in this tutorial, I like to do a simple exercise using the Xilinx Spartan-6 FPGA development board. And today's board that we're using is the Spartan-6 SP601. And the idea behind this exercise is mainly get you familiar with creating a project in the Xilinx ISE software, synthesizing, implementing it, generating the bit file for programming to the board, and just the general constraints on how do you get a Spartan-6 board to interface with the computer and have all the I/O to work. So the goal of this simple exercise is to use these dip switches right here and have these, whenever you turn them on, turn on these LEDs respectively. So let's say that switch 1, if you were to turn it on, turns on this first LED, switch 2 turns on the second, switch 3 turns on the third, and just to change things up a bit, switch 4 will be a reset, so no matter what these states are, these LEDs, whether they're on or off, if you were to turn on switch 4, it resets all the LEDs would be turned off pretty much. So the software we'll be using is the Xilinx ISE 14.7 design suite. If you were to use the new Vivado software, unfortunately they do not support the Spartan 6 series, or from what I know, a lot of the 6 series. So you would have to download the ISE it hasn't been supported since 2013, but it's still up for download on the Xilinx website. If you have any questions or need a walkthrough on that, there are some other YouTube videos that help out with the installation process, licensing, etc. So in this one, I like to give a brief walkthrough on how to create a project and get everything off and running. So on the ISE software here, we have new project. I'm going to click that, and I'm going to call it basic interfacing. You can call it whatever you like to. There we go, typing with one hand. So let's see, I'm going to save it to, I believe I have a Xilinx folder. There we go, and HDL, we're good to go. So in the setup process of the project, this is the most crucial for the Spartan board. Under the evaluation development board, you want to make sure that you click the Spartan-6 SP601 evaluation platform. Depending on what board you have, you want to make sure that you click the corresponding one. In this tutorial, we're going to be working with the SP601. So there we go. We don't have to change anything else on this list. Let's click next and finish. So the next step is we want to create our Verilog file, our .v file for our programming side. So up here on the top left in the hierarchy, if you were to click this board ID, right click that, click new source. This window will pop up and you want to click Verilog module. I'm going to call this, I'm just going to use the same basic interfacing again. Like I said, you can call this whatever you want to, but your top module, you want to make sure it's the same name. So there we go, click next. This is where you can define your I/O, either your input, output, or in-out. This is a quick way for it to be automatically populated when you create the module itself, but we'll just type that in a second. So once that's created, we have our Verilog file here. So what I'm going to do is I'm going to copy and paste the code I have for the interfacing, and feel free to pause it and enter it into your software to get everything up and running. Okay, there we go. So as you can see in my program, it's very, very simple. All I want to do is make sure that the switches interact with the LEDs. So we have a output coming in, or output going out, sorry. That's the LED, it's the 30-bit, so we can manipulate 3 of the LEDs in total. We have the 3 switches that will be inputting, as well as the reset switch. So we're always going to be checking to see if either the switches are changed or if the reset switch is changed. If reset is triggered, set all the LEDs to 0, so turn them all off pretty much. If not, if reset's not active, then start turning on the LEDs with the corresponding switch. Now this is all good to go, and what we want to do is we want to create our constraints file. This is the file that creates the net between our variables here and the switches on the physical board itself. So how you do this is go back to the board ID, right click it, add source. And this time we're going to be clicking implementation constraints file. What I do just for convention is I type in the same name as the Verilog file, but instead of it ending like this, I do another underscore and then constraint, or just CONST. It's just to help kind of keep track of what file is what. So let's generate this and finish. So I'm going to copy and paste the code right here really quick. There we go. So this is the syntax for determining what net on the board is, or what net pretty much of your variables interact with what location on the board. So For the dip switches, I have net switch 0, bit 0, location E12. That is the first switch on the board. D14 is the next switch, F12 is the next switch, and V13 is the last one on that side, if you're going in that direction. LEDs are very similar. We have C4, A4, and C14. I can throw a list of all the ports on at the end of the video in case you want to mess around with other stuff. But this is all we need pretty much. So I'm going to save this file. I'm going to go back to the .v file, make sure that's saved. Now, on the top left here, you have implementation and simulation. So right here, I have my Verilog file. You want to make sure you click that. And on the bottom here, you want to double click synthesize. This will begin to make sure that all your code is correct and there are no issues with it. Let that run through really quick. I'm going to skip ahead so you don't have to wait a few minutes. There we go. So synthesis is complete. We have a check mark, and right here at the bottom says was completed successfully. Now the next step is our implementation. So let's double click that and it'll run through all the routing and etc. There we go. Our implementation is finished. Now the next step is to generate our programming file. You want to double click this, and this one usually takes a few minutes. So we have all check marks along the way. You may encounter a exclamation mark, a warning if you have a license issue, or if you have any warnings throughout your code. That's perfectly fine. Everything will still work. It may throw you off if you don't see a check mark. So lastly, our last portion to finalize everything is to configure target device. You want to make sure that your Spartan-6 is on though, so let's switch over there. So with the Spartan-6, you want to make sure that your power cord is plugged in up here, as well as the USB JTAG. The first side here is a micro USB, and the other side of it goes into your computer, which is a USB. So when everything is plugged in, this little switch up here, we want to click this on, and everything should power on. So let's configure the target device and get everything uploaded. Alright, now that the FPGA is all on and ready to go, let's double click configure target device. Let's click yes on the warning. And now we have this window that pops up. First thing you want to do is double click boundary scan. This will look for any devices that are connected through the JTAG. Now right click the window and say add Xilinx device. From here we are going to find our .bit file, which has all our constraints and our code and everything else. So when you find that, you can just either double click it or click open. And you have this little device that pops up. This recognizes that you got the bit file and everything is correct. So right click that, program. Here on the bottom we click apply, and then OK. So now, if it programs successfully, you should get this little blue box here that says program succeeded. If not, then you might have some errors, or your board isn't plugged in to your PC, or the driver hasn't fully installed yet. But now that we have our thing that succeeded, let's go check it out, see if it works. Okay, so we just got the Spartan-6 to be programmed in the ISE software. So now the goal was to have these dip switches turn on these LEDs whenever you turn them on. So this first switch should turn on this first LED. There we go. Now the second switch should turn on the second, and third should turn on third. Now if you were to flip the last switch on, which we have as reset, this should turn off all the LEDs. And there we go. So let's turn that off. LEDs come back on. Like I said, it doesn't matter what state the LEDs are in, so we turn that back on. And there we go. So we got the basic interfacing to work. The idea behind this was if you're confused on how to create the constraints file or get everything to work, it's fairly simple. The tediousness of reading through the data sheets and everything is kind of monotonous, but in the end you can do some pretty cool stuff. In the next tutorial, I'm going to show you how to interact with these various clocks on the FPGA itself. You have a 27 megahertz clock and a few others, and how to interface with a clock-driven circuit. So thanks again for watching. If you have any questions, feel free to let me know.